Welcome to our introduction on motion in a straight line. In this video, we'll explore the fundamental concepts of kinematics, which is the branch of physics that describes the motion of objects without considering the forces causing the motion. We'll cover several important concepts in this video. First, we'll discuss distance and displacement, then move on to speed and velocity, and finally explore acceleration. Let's start with understanding the difference between distance and displacement. Distance is a scalar quantity that refers to how much ground an object has covered during its motion. It is the total length of the path traveled by an object. Displacement, on the other hand, is a vector quantity that refers to the change in position of an object. It is the shortest straight line distance from the initial to the final position. Let's illustrate this with an example. Imagine a car traveling along a path from point A to point B. The car follows this curved path, traveling a total distance of 10 kilometers. However, the displacement is just 6 kilometers, which is the straight line distance from the starting point to the ending point. Notice that distance is always greater than or equal to the magnitude of displacement. Now, let's discuss how we can represent motion using a position-time graph. In this graph, we plot position on the y-axis and time on the x-axis. This allows us to visualize how an object's position changes over time. For example, this straight line represents uniform motion, where an object moves at a constant velocity. Let's now move on to velocity and speed. Velocity is defined as the rate of change of displacement with respect to time. On a position-time graph, velocity is represented by the slope of the line. For instance, in our uniform motion example, the slope is constant, indicating a constant velocity. Now, it's important to understand the difference between speed and velocity. Speed is a scalar quantity that refers to the rate at which an object covers distance. It only tells you how fast an object is moving. Velocity, on the other hand, is a vector quantity that tells you both how fast and in which direction an object is moving. To calculate average speed, we divide total distance by time. For average velocity, we divide displacement by time. Let's revisit our example with the car to understand this better. When the car follows this curved path, its speed is the rate at which it covers the total distance of 10 kilometers. Its velocity, however, considers the displacement of 6 kilometers and the direction from point A to point B. If it takes 2 hours to complete this journey, then the average speed would be 10 kilometers divided by 2 hours, which equals 5 kilometers per hour. The average velocity would be 6 kilometers divided by 2 hours, which equals 3 kilometers per hour in the direction from A to B. So far, we've been discussing average speed and average velocity, which are calculated over a period of time. But what if we want to know the velocity at a specific instant? This is called instantaneous velocity. Instantaneous velocity is defined as the limit of average velocity as the time interval approaches 0. In calculus terms, it's the derivative of position with respect to time. On a position-time graph, the instantaneous velocity at any point is the slope of the tangent line at that point. Finally, let's discuss acceleration, which is the rate of change of velocity with respect to time. Acceleration tells us how quickly the velocity of an object is changing. It is also a vector quantity, meaning it has both magnitude and direction. The formula for average acceleration is the change in velocity divided by the change in time. Just as we can visualize position using a position-time graph, we can visualize velocity using a velocity-time graph. In a velocity-time graph, we plot velocity on the y-axis and time on the x-axis. The slope of the line on a velocity-time graph represents the acceleration. A steeper slope means a greater acceleration. Additionally, the area under the velocity-time curve gives us the displacement. Let's consider a real-world example of acceleration. Imagine a car that starts from rest and accelerates uniformly to a velocity of 20 meters per second in 5 seconds. We can calculate the acceleration. The change in velocity is 20 meters per second minus 0, which is 20 meters per second. The time taken is 5 seconds. So, the acceleration is 20 meters per second divided by 5 seconds, which equals 4 meters per second squared. This would look like this on our velocity time graph. A straight line going from 0, 0 to 5, 20. Let's summarize what we've learned. Distance is a scalar quantity that tells us the total path length, while displacement is a vector quantity that gives us the straight line distance and direction from start to finish. Speed is a scalar that tells us how fast something is moving, while velocity is a vector that includes both speed and direction. Acceleration is the rate of change of velocity, telling us how quickly an object's velocity is changing. Position time graphs help us visualize position changes and find velocity, while velocity time graphs help us visualize velocity changes and find acceleration and displacement. Understanding these concepts is crucial for solving problems in physics and for understanding the motion of objects in our daily lives. Thank you for watching this introduction to motion in a straight line.